Okay, hi Algebra 1s. There's only two more videos. I'm sure you're getting really sad, but we'll have a unit test after the last one. Don't worry, we'll review a little bit. Um, so after this video, you need to be able to combine like terms. I know for a fact you learned how to combine like terms in middle school. I don't like the way they teach you. I'll show you how they teach you, and then I'll show you my way, which is better, obviously, because I'm a high school teacher. I'm just kidding. Don't tell them I'm better. Um, but this is probably the most important video out of all of them because we're going to be using combining like terms a lot. So you really need to understand all that stuff. Once you're done, you can check the completed box and we'll be good. So go to, I believe yours is page 17, but mine is 15. And we got this combining like terms. So we got a couple notes we'll fill in. So we got to talk about variables. A variable is a blank that represents an unknown value. So this is a symbol that represents an unknown value. So for example, X is one that we use a lot, Y we use a lot, but really any letter is great. The TI Inspire calculators will let you use whole words, but I'm not going to do that to you guys. That would be kind of crazy. Q I like. T, if you use T, make sure you curve the stem so it doesn't look like a plus sign. See how that kind of looks like a plus sign? Bad, don't do that. S's kind of look like fives. Be careful with those. That should be enough. And then like terms is a variable that has the same exponent. Okay, so for example, X would be like terms with X. Those are like terms. Or X and 3X, those have the same exponent of 1. They're understood to be there. Those are like terms. X squared is not a like term with X. Okay? So, same, and then this other variables doesn't really matter. Like Y cubed and 7y cubed are like terms because they have the same variable y and they have the same exponent. Okay, so make sure you know the difference. So here when we combine like terms, we have x and x, same variable, and they both have the first exponent, so we can combine them. We have 7x's plus 2x's, so we really have, if I were to draw a picture, 1, 2, 3, 4, 5, 6, 7 x's, and we got 2 more x's because we're adding x, x. So all of this is really 9x, okay, because 7 plus 2 is 9. All right, that's my way. Over here, we have 7x and x. Well, if there's no number in front, we know that this is 1x. You need to keep that in mind. So 7x plus 1 more x is 8x. You've probably seen this before. Hopefully it's kind of boring for you and we can just move on. By the way, why don't we write 1x? Well, just following these notes. It's easier to just write x. So let's think about eggs. 7 eggs and 1 more egg is 8 eggs. Could be written as 7 eggs plus egg is 8 eggs. The only thing I don't like about this is this should be it should be eggs. Okay, I'll show you why later, but hopefully that just makes a little sense to you. Down here, we've got xy, and xy. Well, we know that there's 1 xy and 1 xy. If there's no number in front, we know that there's only one of them. And then we have these numbers. So in middle school, your teachers make you do this thing where you have a square and then another square because those are like terms, and then maybe you do a triangle and another triangle for these like terms. The only thing I don't like about this is that you don't have the sign. Usually when you guys draw your little triangle, you just draw it around the number, and you don't remember that there's the negative in front, that this isn't 1, it's actually -1. So if you're going to do that, fine. I don't like it, though. I want you to just know that the same variables, the same numbers, I'm sorry, these are like terms because they have the same variables and they're the same exponents. So we have one xy and one other xy. That makes 2xy. Sorry, 2xy. Went a little off screen. Over here, we've got -1 and another -1. Well, we did adding and subtracting integers earlier, so this is -2. So our final answer is 2xy minus 2. Okay, that's a full expression. Those two go together. Number 4. We have like terms because we got x and they're x squareds. They both have the same exponent. So we can subtract just normally. We got 8 minus 2, so we got 6 x squareds. Okay, if you wanted me to draw a picture, you would have x squared, x squared, x squared, x squared, that's 4, 5, 6, 7, 8. And when we would take away 2 of them, take away this one, take away this one, now we only have 6 x squareds. Okay? So now we're going to continue. I want to show you another important thing called the commutative property. Okay? Commutative property. This property means that when you add, subtract, and multiply, the order does not matter, but you keep the signs. Keep the signs that are in front of the numbers. Okay? So 8 plus 6 plus 10 is, well, 8 plus 6 is 14, plus 10 is 24. Well, we could also say 10 plus 6 plus 8. 10 plus 6 is 16, plus 8 is also 24. See how the order does not matter when you're adding? Now we can do the same thing over here, but we got to make sure we keep the signs. So don't think of this as 2, think of this as -2. Don't think of this as 1, think of this as -1. So if we change the order, we could say 3 minus 1 minus 2 plus 5. Okay? I swapped the order, but it should give us the same thing. Let's do the top one. -2 plus 3. -2 plus 3 is 1. 1 minus 1 is 0. And 0 plus 5 is 5. Okay, well now we'll do this one. Well, 3 minus 1 is 2. 2 minus 2 is 0. 0 plus 5 is 5. See how the order doesn't matter? So we're going to combine like terms, but we're going to use the commutative property to help us out. So in number 3, we have like terms here. We got x squared, and we've got another x squared over there. Those are like terms. And we've got numbers, -7 and 2. Those are numbers. And then our third term is positive 4x cubed. Okay, so I'm going to use the commutative property, and I'm going to put the oranges together, the reds together, and the green by itself. So down here, I'm going to write 3x squared, and I'm going to do minus x squared. I put them together. Then I'm going to do -7 plus 2, and then I'm going to do my green one, plus 4x cubed. Okay? Now I'm going to actually start combining. So 3x squared minus, this is how many x squareds? Well, there's no number in front, so we know there's only one of them. This is 2x squared. In my reds, we have -7 plus 2. That's adding and subtracting integers. That's -5. So now we have 2x squared minus 5. And for our green one, we don't do anything. We just copy down plus 4x cubed. Okay, this whole expression down here is combined, and we're done. Now we have 10x squared Sorry, one more thing about this. Typically, we write the highest exponent first. So we have x cubed, and we also usually write it in alphabetical order. This is not as important to me. As long as you combine them correctly, that's fine, but this is a small extension. I'm going to put my highest exponent first, so 4x cubed, and then I have my 2x squared. I don't just write 2x squared, it's positive, we need to add it, and then minus 5. We'll put the numbers last. So this is actually a little bit better. Over here we've got 10x squared and negative 3x squared. I'm going to put those together. And we've got 5x and negative 7x. I'm going to put those together. So my purples, 10x squared minus 3x squared. And my oranges, plus 5x minus 7x. I'll combine them each. 10x minus 3x is 7, or 10x squared minus 3x squared is 7x squared, sorry. And my oranges, 5x minus 7x is negative 2x. There's my final answer. You can see I have a lot of these because they're super duper important. So, in this one, I don't even have any like terms. I got y cubed, we've got y squared, we've got y, and we've got a number by itself with no variables. So we can't combine anything in that. All I'm going to do is rewrite it with the highest exponent first. So we got 9y cubed minus 2y squared. There's the second highest exponent, plus 5y. Sorry for that yellow, I know it's not easy to see. Plus 8, my numbers last. All done. That one was easy. Number 6. I've got x cubed. Those are like terms. I got x squared, and I've got 3x. X squared, I know I have only one of them. Okay, that's understood. This time I'm not going to rewrite it, I'm just going to put them together right now. And don't forget that sign. 2x cubed plus 4x cubed. We now have 6x cubed. Then I'm going to do my x squared second, because it's my second highest, plus x squared. I don't need the 1. If I do write the 1, that's fine. And finally, plus 3x. Okay, 2 more. Bear with me. And now we've got xy and another xy. We've got just x, and we've got just y. Okay, you can't combine the xy's and the x. They're different variables. This is actually 1 xy, right? Because there's no number, so we know there's only one of them. See if I make my 1 a little nicer. Still not great. So we've got 1xy plus 4xy, so that makes 5xy. Orange. I have negative 7x, see that sign in front, and negative 3x, which for a grand total of negative 10x. And finally, plus 9y. All done. This one I thought was a little tricky because sometimes variables are full words. So we got 4 cats and 3 more cats. And then we have minus cat. Cats and cat are not the same variable, believe it or not, because they're not exactly the same letters. I just put that in there to be mean. Don't worry about it. But we got 4 cats plus 3 cats. And minus cat, that's a different variable. So 4 cats and 3 more cats, that's 7 cats. And then we have minus cat. Done. Okay, most important lesson, you need to make sure you got that one down. Sorry, this is a long video.